Hi, welcome to 60 minutes of video with me, Pat Teacle. I'd like to show you some of my gliders and give you some hints and tips on construction of my kits. We'll also take a visit to John Hall and see his moulding shop, and we'll visit Crooks Peak and Ashridge Farm on the Mendips, two of my favourite soaring sites. Now, I started aeromodelling in the early 1950s, and one of the first little model airplanes I made was a paper aeroplane. This was folded from a piece of A4 paper, and there was an article in the Rupert Bear Annual in those early days that showed me how to fold this little aeroplane. Now, Rupert Bear, I believe, is still about. I think he appears in the Daily Telegraph. Now, this little aeroplane had a fully symmetrical wing section, no tailplane, but I can never work out whether it looped or rolled into the horizontal flight when it was launched like that. Going on from there, I soon developed an interest in free flight models, rubber powered models, and we even had a couple of Jetex powered models. By 1958 I became interested in radio controlled models and built a Keelcraft Junior 60 with homemade radio, and there was the receiver, the Hill 2 valve receiver that was in that Junior 60. The Junior 60 was powered by an Easy Racer diesel. It weighed about 3 or 4 pounds. We had a lot of fun. We had to tune the radio before every flight, but it was great fun in those very early days. I really enjoyed it. Coupled to that receiver, we had a very simple servo, a single channel servo. This was designed by a Canadian called Laurie Ellis, and it was designed around a little motor that was very popular in those days, a little electric motor, which is called the Mighty Midget. And that receiver and that servo flew my first radio control models. In 1959 an article appeared in the Aeromodeler by George Upson, and the article showed a drawing, a lot of information on a model called the Aries. This was 6 foot span. It was a slope soaring glider. It was developed from a model called the Archangel. This fascinated me. I thought, this is very interesting. Slope soaring. I built the model up. It was of all built up construction, ribs, spars, tissue covered, and we put this receiver, the Hill 2 valve receiver, and the Laurie Ellis servo into the aircraft, and we flew it off Roper Common in about 1959, 1960. That hooked me on radio control slope soaring, and we had a lot of fun. Of course, many of the early models were of built up construction, balsa ribs and spars, longrons, and usually covered in nylon or tissue paper. But by 1960 the Americans came up with this material called expanded polystyrene foam. There's a piece here, and we started cutting wings from polystyrene foam. This is to cut the polystyrene foam. We use a hot wire. It's a nichrome wire. It's a very simple constructed bow. It's a piece of inch square ramin wood with 2 piano wire struts. The nichrome wire, or the resistance wire, is strung between the 2 piano wire struts. I've got a simple on-off switch here, so it gives me fingertip control of the heat. I'll just demonstrate a simple cut through this piece of foam. The wire's cutting through nice and steady, not too fast, and there's the piece dropping away. The smoke, the smoke from the wire is usually blown away by a fan behind me. So there's how we cut the polystyrene foam. The templates that we use are from aluminium, thin aluminium, 18 gauge, 16 gauge, and to make sure that the templates, the tip and the root are lined up on their datum lines, we use a little cradle from plywood. We cut the cradle from plywood, and the template sits on top of the plywood cradle, like so. To pin the templates onto the end of the block, here's the end of the block there, we use 3 pins. I call them pins, but really they're just 2-inch wire nails with a point filed on. I offer up the cradle to the end of the block, like so. Sit the template in the cradle, a little bit of weight just to steady the block. There's the cradle and the template in place, and I push the pins into the holes in the templates. That's 3 pins. That's the root template in place on the block of foam. I'll now turn it round and pin the tip template on. Find my other 3 pins. There's the block with the cradle and the tip template sitting nicely on top of the cradle. In with the leading edge pin, the trailing edge pin and the middle pin. And there you see the templates are pinned onto the block, root and tip. Now we're ready to cut that core. Move the cradles out of the way, we don't want any obstructions on the workbench. I use 3 weights to steady the work. Here's my hot wire. I'm going to rest the hot wire on top of the leading edge of each template. I switch on the heat. The wire's cutting into the foam now. We're going up over the leading edge. We're about halfway across. No rush, no hurry, no tension, and the wire drops out on the trailing edge. That's the top of the right hand panel of this pair of wings. I take the weights off and turn the block over. The block turned over, we put the weights back on just to steady the block. We're now going to cut the bottom surface of the right hand panel of this pair of wings. We rest the wire on the 2 templates at the root, at the tip. We switch on the heat and the wire is quietly cutting across the templates through the block. Coming out on the trailing edge now. We switch off the heat, put the phone to one side, and now we repeat the process for the left hand panel. There's the cradle, there's the template. We rest the template on the cradle. The 3 pins, 1 at the leading edge, 1 in the middle, 1 at the trailing edge. It's the cradle for the tip template. Go to pin on now the tip template onto the block. Sit in the template on the cradle. There's the last pin in now. There's the 3 pins in. Take the hot wire. Rest the wire on the leading edge of the templates. We switch on the heat. Up over the leading edge. We're about halfway across. Just going steady, no rush, no hurry. A nice, steady, gentle cut out of the trailing edge. Switch off the heat. Take the weights off. Turn the block over. Ensuring the cradles aren't in the way. On with the weights. On with the hot wire. Across the leading edge. Halfway across. 3/4 of the way through. And coming out to the trailing edge, block there now. Off with the templates. Take the pins out. The tip. This is the root. Take away the weights. Now I don't know what's in there, and nor do you. You have a little peek, see what sort of cut we've got. It's a nice smooth cut, very little ridging, if any. And that's how I cut a pair of foam wings. It's quite a simple operation. It didn't take very long, and I would think to cut about, say, 20 pairs of those in about an hour. Now to skin a pair of polystyrene foam wings, we use an Ibishi veneer. It's 0.8 of a millimetre thick. It's got a smooth side and a rough side. We apply a latex adhesive to the smooth side. And the latex adhesive is very similar to Copydex, sort of a creamy consistency. You usually buy it in 5-litre tubs like this, and it's quite creamy like that. It looks like cream, but don't put it on strawberries because it doesn't taste very nice, so I'm told. That's the adhesive. I usually leave it overnight to dry, especially in the winter. And then the next morning, when I come into the workshop, 7 o'clock in the morning, I skin up my pair of wings. Now there's the panel that we cut just now. Let's now assume that that's been glued up overnight and the adhesive is dry. The adhesive was applied to the veneer, and I would then offer up this piece of veneer to the panel like so, and just drop it down over. I would turn it over, turn the panel over, and take my scalpel, there's a new blade in it, and just run the scalpel along the edge of the panel. Put the rubbish out of the way. Now to skin the bottom of that panel, I lay the panel onto the veneer like so. That's not the end of it. To make sure that the adhesive and the skin is bonded well to the core, we give it a rub down with a block. We lay the panel onto the top case because this gives us a nice firm bed, and we rub over the panel with the block like so. We turn the panel over and give the top a rub down like so. We've simplified the operation for the demonstration. Obviously it takes a lot longer than this, but there basically is how I cut and veneer a pair of foam cores. Well, like all good cookery demonstrations, here's a pair of wings that I prepared earlier. These are skinned, the edges are sanded, the leading edge, the trailing edge, the root and the tip are sanded round. That's the right hand panel, this is the left hand panel, and we make sure that they match up neatly. make sure that it all matches up nicely and makes a nice job of it. We check on the tip cords like so, and then finally we pop them back in their cases. These cores come out of these cases, and we pop them back in, slide them back in. This protects the panels, obviously. This one back in. Now to produce the wing panel this long, we've stuck 3 cores together. The cores are cut similarly to how I demonstrated just now. After that, we must cut the slots in for the spars. We use a Ramin spar, top and bottom, on these long glider wings. It's a piece of 12 by 6 Ramin spar. Now to cut the slot, we use a little cutter. There's a cutter there. To cut the servo lead in, or the servo lead tube, which is there, we use a drinking straw tube. And we've got another little cutter. And we've got another little cutter to cut the air brake tube, which is that one there near the leading edge. You can see between the top and bottom spars, we've cut out a piece of foam to allow the joiner to be slid into position later on. Now to cut the slot in the foam core for the spar, there's the spar, made a little cutter up, and all we do is run it along a straight edge. Got a little micro switch on the cutter, got fingertip control. We just cut out a piece of foam that's 6mm deep, 12mm wide. It's a little demonstration piece that I prepared here. We take out the strip, there's the strip, and we replace it with a piece of Ramin. And the Ramin spar sits in to the core like so. To fit the tube for the servo lead, there's the servo lead tube. Change the cutter, and this little cutter produces a slot 1/4 inch in diameter. And we quietly run that little cutter along the straight edge. We're halfway along this little block now. There's the slot cut out. Pull out the waste and we can slide the... Right, well, we cut the little hole and we slide in the servo lead tube like so. And there's the servo lead tube fitted. It runs all the way along the underside of each wing panel. Right, we need a fiberglass fuselage for our kit now. So I think we'll just walk along the road and see John Hall in his moulding shop. Well, we've walked along the road a few hundred yards to John Hall's moulding shop. Good morning, John. We've come to collect an ASW20 fuselage. Luckily, he's got one ready for us. Now, it really is a beautiful fuselage, John, a beautiful finish. But how do you go about it?
Well, Pat, here's the mould I made some years ago now for the ASW20. It's basically the same material as the fuselage is made from,
right.
But we have to apply a good few layers of wax to get a good release so we don't get any fuselage sticking up.
The wax, now that's interesting. The wax is obviously to release the fuselage out of the mould.
That's correct.
Now once I was talking to my old granny and she asked me about this process of fiberglass moulding, and I said to her, well, Gran, I said, I could best liken it to you making some cakes. I said, you grease your tin out, put the mixture in and the cakes pop out. Now is that a similar sort of process?
In principle it is quite similar, but as I said, the taste isn't quite the same.
It's a different sort of taste?
Yeah, the texture, you know.
Right, thank you very much, John. Well, John, after waxing up for the release, what's the next stage?
Well, Pat, we have to put the colour in this case a white one. I've got one over here I've done earlier, as they say, and that's the gel coat.
That's the gel coat?
Yeah. It's just,
and how do you apply that?
Just paint it in with a brush, smooth it all out, and then that has to be allowed to set before the reinforcements put in.
I see. Yeah. Okay, thank you. Well, John, once the gel coat is cured, I assume you cut out your bits and pieces of fiberglass, your chopped strand mat, and then you lay them in. Is that right?
That's right. The gel coat, once it's set, still stays a little bit tacky on the surface, and all these shapes are pressed into position. Then I mix up my resin with a little bit of white in it, just to back up the colour of the gel coat.
Yeah.
Brush it all into the mould, and then set about it with a roller to break down the fibres to make it lighter and much stronger, more flexible.
Yeah. But you apply the resin with a brush?
Yes.
Yes, yeah. And then you roll it in. And what's the tape for?
After the chop strand mat's all in and rolled, I put reinforcing tapes in places such as the boom to increase the tensile strength so that when things flex they don't crack and go too far.
Yeah. I see. Once you've got the chop strand mat in, what's the next process? You also got to wait for the resin to cure off.
That's right. Once the resin's sort of half set, it gets to what we call the green stage, and where it's sticking up proud of the edge of the mould like that, we can just trim it off, shear it off with a knife, and then the joining tapes, the strips are placed in. The resin is then placed onto those, and the two halves are bolted together.
You bolt the two halves of the mould together?
Yeah, this mould's got lots of holes, as you see, all the way down it. Lots
And
of bolts and wing nuts go in those.
Yeah.
And then with some long versions of this, a longer brush and a longer roller, I work on those to join it.
I see. And what do you actually put along the join inside to join it?
Strips of the same chop strand mat, and in some places woven tapes like this.
A woven tape like this?
Yeah.
Now, is it true, John, that to draw the tape through the fuselage, you use a little mouse and you tie the tape to his tail and he runs through for a piece of cheese? Now, is that right? It's a story I've heard, but obviously you know if it's right or not.
Well, it goes back a long way, that story, and there's a little bit of truth in it, but on these larger fuselages we tend to go for a ferret or a weasel.
I see. Thank you very much.
You're welcome.
Thank you. Well, John, I see you've got the two halves of the mould bolted together. There's a fuselage inside, and you tell me now that the resin is cured off and you can take the fuselage out. I'm excited by this. I want to see how it's done.
Okay. So we just finished taking these wing nuts and bolts out, Pat, and we can take the fuselage out.
Great.
Right. Gently lie it on its side.
Right. It's quite a heavy mould, actually.
Yeah.
It's, I think you've got to have a strong arm for this sort of work.
it. And then we just sort of prise the two halves apart.
Right. Yep. Right. Shall I take that half?
Yes,
Out of the
please.
way. Right. There we go.
And there we have it.
There's a beautiful fuselage. Let's have a look, John. Perhaps you'd like to lift it out.
Okay, here we go. Just a minute, and there we are.
Wow, that is beautiful. That is beautiful. Lovely, John. Thank you very much. Well, we've produced a pair of wing cores for the ASW20. I'll just show you how I apply the leading edges and the trailing edges. The leading edge material is a pine strip. It's about 3/4 of an inch wide and about 3/8 of an inch thick. Because of the double taper on the ASW20 wing, we need to splice the material for the leading edge, and these I've done previously. We can hold the strips on with sellotape every so often just to hold it in place while the glue dries. The glue I use is the Flair White Set glue, which I find is very good. The trailing edge material is balsa, and there's a strip of balsa just for demonstration there. I've glued that piece on. Now, I've cut that piece wide enough to incorporate the spar, which you must have on the trailing edge of the core, on which to hinge the flaps and the ailerons. Then that strip incorporates that trailing edge. I shall now plane and sand that material right down to the correct profile, and I find the Stanley plane or the little David plane is very useful for this sort of work. I will plane that down and plane the leading edge right down to section. The section for the leading edge, you can take off the wing loop fairing on the fuselage to get the correct profile. Well, having glued on the leading edge and the trailing edge material, we must now, as I say, plane it down to the correct profile. You can take a template off the fuselage on the wing root fairings. I'm obviously using my template from the workshop. I'm a little bit lucky there. And I've now placed the template onto the end of the wing core, and I've just penciled in the leading edge shape there and the trailing edge shape there. I can then plane it down to section. Now the slot that you see between the top and bottom main spars is to take the wing joiner. Now the piece of foam that I cut out from there, I retain because it is tapered from root to the outer end. I can use that now as a template to shape my wing joining assembly. Now wing joiners. Now on the ASW20 and on most of my big gliders, we use the 15mm steel strip. There's the steel strip in the brass box. We only need one strip in an ASW20. Now the steel is sandwiched between two bits of 16th plywood, and it's capped top and bottom with further hardwood, and then if we need a bit more packing either towards the leading edge or the trailing edge, we can use a hard balsa. Once that assembly is made up, the sandwich, the plywood steel sandwich, we can shape it using the foam cutout until we obtain a good fit into the slot, which is 8 inches deep in the case of the ASW20. Yes, as I say, the wing joiner then is 15mm steel. It's quite important to degrease the steel, and the section that's actually sandwiched between the plywood, I file some notches into it to give a good key for the epoxy glue. Then on the underside of each wing panel, you'll see two little pencil crosses. Now the one near the root is the exit for the air brake cable. That's that one there. And the other little pencil cross, a bit further out, is for the air brake servo. And that indicates the end of the servo lead tube that we showed you earlier. You would cut in this position a slot to take your servo, and on my particular models I use a high-tech Mini with metal gears, and the that servo would be fitted in there. Now going back to the air brakes, having located the end of the tube, there's the pencil cross there, I would take a thin piece of wire, push it right through the wing core until it protrudes on the top surface. That then tells me where the end of the tube is relative to the top surface. I would then cut the slot in for the air brake, and this is a pair of multiplex air brakes. I would cut the slot in the top surface just behind the main spar and drop them down in, connecting up the Bowden cable to the arm on the air brake. Well, having prepared the panels, as having shaped and sanded down the trin edge, the leading edge, we're now ready to glass up the panel. We use a lightweight skinning glass. This is from Flair. It's 0.6 of an ounce per square metre weight glass. I've laid it up onto the wing. I'll just use little weights. There's just a pair of scissors there. There's a little scalpel there, just to hold it in place while I work it. Now, I use Flair or Tough Coat, available from any model shop as an adhesive. A lot of people use epoxy resin SP113, but the Tough Coat goes off a lot quicker, and you can cover in glass a pair of wings of this size in an evening. There's the Tough Coat there. We mix up a little pot. This is a washing up liquid plastic pot. Very, very useful. My wife saves me all these little pots. I've got a shed full nearly. I mix that up as per the instructions. There's little graduations on the side of each bottle, and all we do with a brush is just brush it through from the middle, always working outwards in a sort of a figure of 8 or an S-shaped action like that, but always working the resin, the glass outwards. This dries out any bubbles. We get a nice smooth surface. There we are, just work along there towards the root and the leading edge. And you can see that it goes on nice and smooth, and a nice smooth finish, just like that. It usually takes about 20 to 25 minutes to cure off in a warm room. I'm thinking of perhaps 55 to 60 degrees Fahrenheit. And then we can trim it off using the scalpel with a new blade in it. Trim it off all around the edge. I usually cover the bottom surface of the wing first, and then afterwards the top surface. And as I say, a pair of wings of this size you can usually cover in glass in an evening. It's a lot quicker than using the other resins, and I think it's just as good. I've done a lot of models with these materials, the Tough Coat, and I don't get any problems. So during the process of shaping and the leading edge and trailing edge, we often just snick the veneer up with the David plane or the scalpel. It's one of those things that happens. We get a bit too enthusiastic about the shaping, and when we think that things are going really well, we might just snick up the veneer in places. Now if this happens, or you get any other damage, perhaps something's frightening you, you've dropped the wing, and you've got very slight damage to the veneer skin, we can use a little bit of filler, a Tetrin filler I use. This is a powder. Mix it up with a drop of water, you plaster it on. When it's dried out, it's very, very easy, simple to sand down to shape. The air brakes. Now, we can't just drop the air brake into the slot with the metal edge of the top blade showing. So what I do, I glue, using super glue normally, a piece of fairly hard 1/8 balsa on top of the blade there, and also a piece of 1/8 balsa on the edges of the air brake box, along that edge there, and also along the other edge. So when you drop your air brake down into the slot, we leave the balsa slightly proud. When it's glued in, we can then sand off the edge of the balsa just to maintain the correct profile of the top of the wing. Once you've got your glass skin on, I apply another coat of the Tough Coat. just giving it a light sanding down between each coat. I'm then ready to apply the